All right, guys, we're talking today about the fundamental counting principle. All right, this kind of goes hand in hand with probability, which is the next section. We're going to talk about permutations and combinations, but you guys are going to have to think a little bit on these problems. Not too terribly much, but you are going to have to think a little bit and kind of pay attention to what they're talking about. All right, if you look at this first example, it says 8 pieces of paper are numbered 1 to 8 and placed in a box. One piece of paper is drawn from the box, the number is written down on it. The piece of paper is returned to the box. Why do you think that they have that italicized right here? It says that it was returned to the box. Do you think that's important information? Yes. All right, how many pieces of paper are there? 8. All right, so if I have a box and I take a piece of paper out and I look at it, and I put it back in, how many pieces of paper are still in the box? 8. If I take the piece of paper and I put it over here on my desk, how many pieces of paper are left in the box? 7. Okay, so those are the kinds of things that we have to pay attention to. We're going to talk about with replacement, without replacement, and all that stuff. This is probably the hardest question that we're going to deal with right now. I don't think I put any of these on your web assignment or anything like that, but the question asks, then says a second piece of paper is drawn from the box and the number is written down. Finally, the two numbers are added together. And how many different ways can the sum of 12 be obtained? What does the word sum mean? 12, right? You're going to add two numbers to get 12, correct? So that's what we're looking for. Sum of 12, right? And you're going to use how many different numbers? How many pieces of paper did they draw out? 2, right? Yeah. And the numbers 1 through 8 are on the box. So think about this. The first piece of paper, our second piece of paper. Using the numbers 1 through 8, can I add 1 plus 1 and get 12? No. 1 plus 2? No. 1 plus 3? No. What can I start at? What are the first two numbers that I could add together to give me 12? 8 plus 4, I agree. So just think about it. If I drew a 4 in the first one and an 8 in the second one, does that give me 12? Yes. Okay. What else can give me 12?
6 and 6.
Okay, 6 and 6. I like that. 6 and 6 gives me 12. What else can give me 12?
7 and 5.
5 and 7. Good. 5 and 7. I'm just writing them in order because I like the way it looks. How else can I get 12? If I first draw a 4, and then I get an 8. Then I draw a 5, I could get a 7. I draw a 6, I could get, what else can I draw? Can I draw a 7 on the first time?
Yeah.
Then what would I have to get on the second one?
5.
Okay. Can I draw an 8 on the first one?
Yeah.
What would I have to get on the second one? 4. So there's 1, 2, 3, 4, 5 different combinations. Yes?
So even if it was same, just flip, you still...
Yeah, because you're two different drawings. All right? You guys understand that? I'm going to give you some formulas that are going to make this really easy. You don't have to do, like, the thinking part. But do you understand what we just did? How we just obtained those numbers? Yeah. David, you just walked in, so come on. Hang on one second. I have to mark David present. Hang on. All right, so let's look at the next one. All right? It says 8 pieces of paper are drawn at the same time, all right? I'm not going to redo this one right now with you. Well, I guess we can. Drawn at the same time. If they're drawn at the same time, think about this. I got my first and my second. So I could get a 4 and an 8, right? I could get a 5 and a 7. I could get a 6 and a 6. And I could get a what? If they're drawn at the same time.
7 and a 5.
4, 5, 6, 7 and a 5. Well, if they're drawn at the same time, 5 and a 7 and a 7 and a 5 are the same thing, right? Because we're not putting it back. Anything else?
No.
Okay, so then how many this time?
3.
3 different. All right, I'm showing you this because it's the same premise. It's still the same 8 cards. We're still trying to get the sum of 12. But the only thing that was different is that we drew them at the same time. Up here, we drew them one at a time and one was replaced. I'm trying to show you guys the importance of paying attention to what the problem says. Right here, this is really important. We just talked about this a little bit. If something has replacement, that means it's put back. A lot of times you'll talk about a deck of cards, a bag of marbles, something like that. If you replace it, the number that was originally started with stays the same. If it's not replaced, what happens to the total number? If I have a bag of 10 marbles and I take one out and I put it over here, how many are left in the bag? 9. So the number will decrease by however many you pull. Usually it's 1, but sometimes you pull 2, something like that. All right, does that make sense? Okay. Yes, ma'am.
For the first one, when they pull this out.
All right, so let's look at a problem like this. All right, we're talking about the fundamental counting principle. That what I'm talking to you about is written right here. It's talking about events occurring and how many different ways they can occur. So let's just think, okay? You guys are just using your brains and we're thinking. How many different pairs of letters from the English alphabet are possible? Now, here are some things that you guys need to know. We need to know how many letters are in the English alphabet. That's what's called common knowledge. 26. There's 26, Carla. Okay. Oh, it's Monday, I got it. There's 26 different letters, correct? Okay, so what does the word pair mean? There's 2, right? So you're going to have a letter here and a letter here. Agreed? Since we're a pair, there's going to be 2 of them. So how many choices, how many available letters are there for your first letter, your first pick? 26, okay. How many different letters are there for the second pick? 26. It doesn't say anything about taking them out of a box or anything. We're just talking about the letters in the English language. So in order to figure out how many different pairs there are, you're going to multiply these numbers together. We're always going to be using multiplication here. So 26 times 26. Somebody do it for me. What is it?
676.
There's 676 different ways. Now, another way that you could have figured that out, you could have written, okay, A could go with A, then A could go with B, then A could go with C, right? How many times would you have to write down?
600 times.
676 times. Does anybody want to do that? No. Okay, Carlos, you can, honey, with all 27 of your English alphabet.
So wait, if it's 27, we're going to be 678.
It's not 27, sweetheart. It's just 26. Oh, bless. So, guys, the fundamental counting principle is going to give you different combinations and permutations. We'll talk about that in a second. There's buttons on your calculator that do this, but you're going to have to show me formulas. You are going to be able to calculate these things without having to write out, okay, I can pull out a 4 and an 8 and get 12. I can pull out a 5 and a 7 and get 12. There are mathematical formulas that will give you that. Same thing here. I don't have to write out A goes with A, then A goes with B, then A goes with C, then A goes with D. You don't have to write all that stuff out, okay? Make your life a little easier here. So let's look at this. Fundamental counting principles when we just multiply everything together. So it says a telephone number in the United States currently has 10 digits. Ooh, digits. How many? 10. So let's write out 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Read what the rest of it says. First 3 are the area code. So here's the area code. And the next 7 are the local telephone number. Agreed? Agreed?
Yeah.
Right? Okay. So it says how many different telephone numbers are possible within each area code. So if they're talking about within each area code, do I have to account for anything in here?
Yeah.
We're talking about these are all in the 954s or the 786.
Yeah.
They want to know how many is in each area code. So I don't have to worry about those first few. All I have to worry about is the local number. All right, this is our local number. This is my area code, but it wants to know how many are in each area code, so the area code is going to stay the same. Note that at this time, a local telephone number cannot begin with a 1 or a 0. So they gave you some sort of rule. They told you that the first digit cannot be what? This one right here cannot be a 0 or a 1. Cannot be a 0 or a 1. Now we're talking about digits, guys. From 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many digits are there? There's 10. Everybody understand that? Okay, there's 10 total here. 10 total digits. So the first one cannot be a 0 or a 1. So how many possibilities are there? 8. Good. The rest of them, are there any rules? No, could be anything, right? From 0 to 9. So how many possibilities are for this second spot? How many total digits are there? 10. So how many for the third spot? 10. How many for the fourth spot? 10. How many for the next spot? 10. Now I could change this question and I could say the digits cannot repeat. So I would have 10 here, then I would have how many here? Then. Okay, so you guys understand. It doesn't tell me that they can't repeat or anything like that. Well, the fundamental counting principle tells me to do what when I have all those numbers? Do we add them? No, we multiply them. So when you multiply this, ladies and gents, what do you get? 1, 2, 3, 4. There's 6 zeros. So there's 8. How many? What does that say? 8 million. I think I spelled possibilities wrong. There's 8 million possibilities. Or you could try and figure them all out by writing them out by hand. Not so much?
Nope.
Okay. All right, before we move on to the next slide, I do want to talk to you guys about something. You'll see this on WebAssign. This isn't on your notes, but you'll see this on WebAssign. Say there's a 10-question test, and it's true-false. Okay? If I'm talking about 10 questions, how many spaces do I account for? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, guys, how many different ways can you answer a true-false question? So there's 2 different ways here. Then what? For the second question, how many ways? 2. Then what? Then. And what do I do with all those 2's? You multiply them, okay? Lots of times they ask this fundamental counting principle question with either area codes, like we just did there, like when you have to account for the digits, or tests. What about if it was a multiple choice test with 4 answer choices possible? 4 the whole way. Okay, good. Good. All right, let's move on to the next question then. All right, guys, we're going to talk now about permutations. There is a permutation button on your calculator. I will show it to you if you would like to see it later on in life, not right now. But with permutations, I want you to write down right here. This is super important, Carlos. Order matters. All right, we've already talked about combinations. You guys already know that formula. But in a permutation, order matters. Generally, you'll see questions about when quote-unquote order matters. We'll talk about like running in a race. Does it matter? It should. Does it matter to you if you come in first, second, or third? Yes. When they talk about running for like secretary, president, vice president, does it matter? If you're running for president, you want to win president. You don't want to win secretary. Combinations would be like if you go to Subway and you get a sub. Does it matter if the pickles go first or the lettuce?
Yes.
No. If you're choosing classes, like for your schedule, you can choose from 3 sciences, 2 math, and something else. Does it matter if you pick the science you want to do before you pick the math? No. So that's where you guys are going to have to distinguish, does order matter in this situation? So let's look at this. How many permutations of the following letters are possible? Since they told me it was a permutation, what are you going to say? Order what?
Matters.
Order matters, all right? So how many different letters are there? 6. So there's 6 spaces. 1, 2, 3, 4, 5, 6. So for this first spot, Carlos, how many different options do I have for that first spot? How many different letters are there? 6, okay. If order matters, can I repeat the letters? No. So then how many are left for the second spot? 5. Then what? Then what? Then what? Then what? And what do I do with all those numbers? Multiply them. What's another way that I could write this?
The exclamation point.
Yes, this is the same as 6 factorial. Well done, well done. And what is 6 factorial? It's 720. Good job, Addison. Good. All right, so now we're going to talk about some more permutation kind of things. How do I know that this is a permutation? It doesn't say use permutations, but how do I know this is a permutation? Because order what? Order matters, guys, when you're running a race. How many horses are in this race? 8. All right? 8 horses are running a race. How many different ways can these horses come in first, second, and third? What are the only 3 things that matter in this race? Do all 8 horses matter?
No.
Just what? Just what places? First, second, and third.
Technically first, but we're just going to say that.
So how out of the 8, right? One of them can come in first. So what's the possibility that the horses can come in first? Right. Then what? Since one of them's going to come in first, then there's how many left for second? Then there's how many left for third? Good. So now what do you do with those 3 numbers? And you get 336.
But we don't keep factorial, right?
Nope. No, because it's not, they only want the 3 places. If they wanted to know how many different ways they all could come in, then that would be. Now, this is the formula for permutations. Does this look familiar? Is it the same as combinations? It's without the what? Perfect. Yep. Look, you guys have already done combinations. Whoops. Right? Permutations, as Julian just told us, it's the same thing. It just doesn't have that R. So if you had a question like this, and it's a horse race, and they want to know what are the different ways that it can come in first, second, third, or first through fourth, or whatever, you can use your permutation formula. You can say, okay, how many horses are in this race? 8 horses. And how many different places am I concerned about? 3. So you would say 8 permutate 3. You literally would just say 8 factorial over what? 8 minus 3. So you get 8 factorial over 5 factorial, right? When we work this out, we get 8 times 7 times 6 times 5, what? Factorial over 5 factorial. What happens to 5 factorials? So this equals 336. Permutations and combinations. Permutation order matters. Combination it does not. Questions? We okay? Everybody's all right? All right, scooting along. That's exactly what I just told you. Right here. All right, see they did it. I just did it again. Okay. Distinguishable permutations. This is the only time you're going to have to do this, and it's always with letters. Always, always, always. Distinguishable. That means different, all right? That means we're going to have a permutation. Whoops. T-A-T-I-O-N. All right? Whenever you are dealing with letters, this is always going to happen, and it only happens with letters. You guys will have one of these on your test, I'm sure. You'll have one of these on your web assign, that sort of thing. It says, in how many distinguishable ways can the letters in banana be written? All right, well, let's write out the word banana. B-A-N-A-N-A. Agreed? Okay, how many letters are in the word banana?
6.
There's 6. So 6 factorial.
That's it.
Hold on. It would be if all the letters were different, but they're not, right? Do you see any letters that repeat? Because they say for distinguishable, that means they want all the different. So what you have to do is divide If none of the letters repeat, it's just factorial. But if the letters repeat, you have to divide out the repeating letters. So what repeats? Okay, how many times does A repeat?
3.
So I have to divide out by 3 factorial. Does anything else repeat? N. How many times does N repeat?
1.
So 2 factorial. Well, does this just equal 0? No. Can you multiply the 3 times 2 on the bottom and get 6?
Yeah.
No.
Never mind.
6 times 5 times 4 times 3 times 2 times 1, right? Then on the bottom I have 3 times 2 times 1 and 2 times 1, correct?
Yeah.
Okay. So 3 will cancel out with 3. 2 cancels out with 2. And this 2 can cancel here, right? So I'm left with 6 times 5 times 2. How many different ways can you arrange the letters of banana? 60. You only have to do that and worry about dividing out repeats when they talk about letters. One that they like to use a lot is the word Mississippi. Right? We got S's that repeat, we got I's, we got P's, that sort of thing. That only happens though with letters, so you guys will be fine. All right, now we're going to talk about combinations. Combination order what? If permutations order matters, combination order does not matter. And we've already talked about these last, I don't know, 8-1, 8-2, 8-3, something in there, right? You guys already know what this formula is. So if they just give you a combination with 8 and a 2, you know how to fill this in. If they give you a permutation with a big P, like 10 permutate 4, you guys know how to do that. But you're going to have some word problems. And then we're done. This is it. What's up? The formula. All right? It says, in how many different ways can 3 letters be chosen? What is super important about this question? What did they just tell me right there?
The first 3 doesn't matter.
The order doesn't matter. So they're telling you that this is a what? A combination or a permutation? Combination. So my combination formula is n factorial over n minus r factorial, r factorial, right? Agreed? Yeah. Okay, I know I'm going to use that. So let's look at A. Let's see what they tell us. How many different ways can 3 letters be chosen from A, B, C, or D, or E? So how many different letters are there? 1, 2, 3, 4. How many?
5.
There's 5 letters. And how many do they want us to choose? You guys have to be able to read. Come on.
3.
3. We want to choose 3. So I have 5 total, and I want to know how many ways I can arrange 3 of them. Guys, the bigger number always goes first. So you would plug this in, and you'd say, okay, 5 factorial over 5 minus 3 factorial times what? 3 factorial. Good. So 5 times 4 times 3 times 2 times 1 over, what's 5 minus 3?
2.
So 2 factorial, 2 times 1 times 3 factorial, 3 times 2 times 1. Okay, so 2 cancels with 2, 3 with 3. What else?
You can simplify 4 and 2.
You can simplify here, yep. So how many different ways?
10.
Or you guys could go, okay, I can do ABC, I can do ABD, I could do ABE. Or I could do BAC, or right? Like you can write it all out and see how it would work out. I would just use the mathematical formula so you don't miss anything, you don't get confused. Because especially for letter B, all right? It might be easy for you guys to figure out the 10 different ways, but look what letter B says. Standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? It says after the cards are dealt, the player may reorder, so order is not important. If order was important, it would be what? The P one, right?
Yeah.
Permutation. Since order is not important, it's what? Combination. So how many total cards are in the deck? 52 cards. And how many are you dealt?
5.
Okay, so you're dealt 5. I'll say there's 5 cards per hand, or however you want to say it. Since order doesn't matter, I'm going to use combination. So it's 52, big C, little 5. Work it out. 52 factorial over 52 minus 5 factorial times 5 factorial, correct? You guys with me? Okay, so 52 factorial over, what's 52 minus 5?
47.
47, yep. Times 5 factorial. And now you just write it out. So 52, 51, 50, 49, 48. Why am I stopping at 47 factorial? Because I have a 47 factorial on the bottom. So those cancel. 5 goes into 50 10 times. Okay. 4 go into anything? Okay. 4 goes into 48 how many times? Does 3 go into anything? 3 goes into 51 17 times. What about 2?
52.
Okay. 2 goes into 52 what?
51 to 17.
Yeah. 26. So let's multiply together. 26 times 17 times 10 times 49. Whoops, I should turn my calculator on. 26 times 17 times 10 times 49 times 12. What'd you guys get?
2,598,960.
960 ways. Now, would anybody like to write out by hand all 2.5 million ways that your poker hand could be dealt? No. No, 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 no. So remember, guys, if they tell you order doesn't matter, it's a combination. They don't have to outright tell you. They could, if they talk about a horse race or people running a track, or think about how many different ways someone can sit in a row at the movie theater. Is that a permutation or a combination? Can everybody sit in the same seat?
Oh, no.
No, right? If there's 10 people in a row, once someone sits in that first seat, how many available seats are there? 9. Then once someone sits in that one, how many available seats are there? 8, right? So it's just going to go down like that. That's a permutation. So you could either do 9 times 8 times 10 times 10, or you can use the formula. It does not matter. You guys can figure this out. You can use either way you want to. So tomorrow in class, you guys are going to have the entire class period to work on your web assign, ask me questions. This will be tested next, when we get back from spring break. On April the 14th, you guys have a test over 8.1 to 8.5.
No, wait.
So we're done now. We're done. Before spring break. I'll upload this video now.